Good morning. So today we're going to talk about one-step equations, which is a bit of an extension of when before geometry, we were doing expressions. And we learned that expressions are the parts that make up equations. But equations have an actual equal sign attached to them and that we actually solve them. Whereas with the expressions, we only simplify them. For today's notes, we are going to be on page 145, and we're going to put this table on 145 with some practice problems. And we're going to be on 146, and on 146 we're going to put our note page. For this set of notes, you are also going to need to have 4 Post-it notes, 4 of them, ready to go. Your topic for today is going to be one-step equations. And the essential question is, how does the inverse operation help us to solve equations? How does the inverse operation help us to solve equations? You're going to be doing standard 6, expressions and exponents, or expressions and equations 7. And we are going to need to know how you can solve, you can write and solve one-step equations. And to do this, in order to write and solve one-step equations, we use what we call the inverse operation. Now remember, operations are multiplying, dividing, adding, subtracting. Those are all different operations. Inverse means the opposite. So if I were to take a student and I were to invert them, or do the inverse of them, I would take them from a standing straight up and down, and I would flip them and have them be standing on their head. That is the inverse position of a person. It's the opposite of what normally we would do. So in this case, the inverse operation would be the opposite operation. So we have this practice problem, 7x equals 14. And we're going to solve that using the inverse operation. And remember that inverse could also mean opposite. All right. So we're going to take our first Post-it note. And what we're going to do is we are going to write inverse operation. This is our process. That one was easy. So inverse operation. Now, put that to the side. Then we're going to take our second one. And we're going to write our definition for inverse operation. To use the inverse operation, we are going to isolate. Now, isolate. Isolate, if I were to isolate a student, let's say I were to isolate Lainey. To isolate Lainey would mean that I would take her and put her all by herself. So if Lainey was being naughty in class, which she's never naughty in class, I would isolate Lainey from the rest of the class so she didn't distract the rest of the class. I would take Lainey and I would send her into the pod and say, Lainey, you're isolated, go to the pod. She would be by herself. Well, in math, when we isolate, we are also getting something by itself. And in most cases, we're getting the variable by itself. We're isolating the variable. We're putting the variable all alone. Okay, by itself. So get by itself. The variable needs to be alone. And this always reminds me, and bear with me for a moment, but of a song. It reminds me of a song that I used to do when I was in kindergarten called The Farmer in the Dell. In The Farmer in the Dell, a lot of things happen, but at the end, there's the cheese, and the cheese stands alone. And so you sing this whole song where, like, the farmer takes the wife, hi-ho the dairy-o, the farmer takes the wife takes the child, hi-ho the dairy-o, the wife takes the child, and you go through this whole line until you get to the cheese. And when you get to the cheese, it's the cheese stands alone, hi-ho the dairy-o, the cheese stands alone. I don't know why the cheese stands alone. I don't know if it's stinky cheese, if it's blue cheese, but the cheese always stands alone. And so I just, for some reason, when I'm thinking about variables, that song always goes in my mind. The variable stands alone, hi-ho the dairy-o, the variable stands alone, and now it will always be in your brain too. So, you're welcome. So, the key is, the variable is isolated. It is what? Standing alone. So we need to get it alone. Well, how do we get it alone? You get it alone because you have to do the opposite operation to undo it. Okay, and I'm going to write at the bottom, isolate the variable. So, in our example, we had 7x equals 14. Okay, that was our example that we had. So we're going to look at this x, and we're going to decide what is happening to the x. Who can look at the 7x and tell me what is happening to the x? What are we doing to it, James?
We're multiplying 7 by x.
We're multiplying the x by 7, right? So that's the operation. Now we need to undo the operation. So what is the opposite of multiplying by 7? What is the opposite of multiplying x by 7? What is that opposite, Cody?
Divide.
Divide, because we know that the opposite of multiplying is dividing. The opposite of addition is subtraction. So I'm going to make myself a little note. So the opposite of dividing is multiplying. The opposite of addition is subtraction. So I'm making myself a little note so I remember. Okay, so the opposite would be to divide. So to divide, I just put a little division line bar. We put the division bar because that means the same as to divide. I could do 7x with a little dividing by 7, but I like to do this because I think it's easier. So that's our first step. That's the opposite operation or the inverse operation. Okay, so now I'm going to take this Post-it note and we're going to put it to the side. All right. So on this one, we are going to remember to be fair. We're going to be fair. And that means we must be fair and divide by 7 on both sides of the equation. Meaning, whatever you do on one side of the equal sign, you do on the other side of the equal sign. So, previously we did 7x divided by 7 equals 14. We did divided by 7 on this side. Now what we have to do is we need to divide it on the other side of the equal sign. So I'm going to make a division bar over here, and I'm going to make it divided by 7. So now I'm fair. I've balanced out my equation. Have you ever in science or math class used a triple beam balance where you have to balance, you put weights on one side and it goes up and down? Or have you ever seen with like in American history when we talk about our judge and our legislative system, they'll show oftentimes the scale, and that scales to show it should be fair and balanced, and the whole idea is to balance. And so you would put weight on one side, but then you have to equal it out, so it's not like a teeter-totter. Think of a teeter-totter. If you get one person on one side of the teeter-totter, and then you put two people on the other side of the teeter-totter, the teeter's not going to totter. So you got to put two people on both sides of the teeter-totter to equal it out so it teeter-totters. Otherwise, you're just going to be tottering. So it's the same thing with an equation. You have to put it and make it balanced. Whatever you do on one side, you have to do on the other side. Okay? So we're going to now take that Post-it note and put it up here, out of the way. We're on our last Post-it note, you should be. And this one is answer. So now we're going to answer it. You have 7x divided by 7 equals 14 divided by 7. The first thing we're going to do is we're going to say 7x divided by 7 is going to leave us with just x. We've now isolated our variable. The cheese is now standing alone. He's by himself. He's happy. Now we have to go to the other side and balance it out. We have this divided by 7 on this side. Well, we're going to do 14 divided by 7. Well, what class is 14 divided by 7? 2. Circle your answer. And that is it. You're done.
Wow.
I know, life-changing, right? Okay, so, yes.
Instead of doing that entire process, couldn't you just figure out that it's 7 times 2?
Okay, so here's the thing, James. You are a brilliant man. And I have every year some equally brilliant people like you who are like, dude, it's not that hard. Why am I doing all these steps? The reason you're doing all these steps is because it will get hard. And you have to learn the pieces in order to be able to do a more complicated puzzle later on. So for this part, as mundane and tedious as it may seem, yes, I want you to do all of the steps. Because in the end, it'll get them cemented into your brain, and when you get more complicated work, which will come, you'll still remember the easy steps in the beginning. Okay? So yes, I know it seems redundant, but please do it. So we're going to put these together. One second. And it's going to look like this. So I just stacked them all up, so it should say inverse operation, isolate the variable, be fair, and answer. All right, so now we're going to move down to our practice problems. The first one, 2 plus y equals 14. So the first thing we need to do according to our steps is isolate the variable by doing the inverse operation. We're going to get that variable alone by doing the opposite. What is the operation that we are doing to the variable? What are we doing to y? Raise your hand if you can tell me, what are we doing to y in this problem? What are we doing? Michaela?
We're adding it to 2.
We're adding it to 2. So it's y plus 2. So what is the opposite of plus 2? What is the opposite of plus 2? Carlos? Minus 2. So we're going to subtract 2. So that's going to get our y by itself. But whatever we do on one side, we've got to balance. Think of our teeter-totter. What do you do on the other side? What do we have to put on the other side of the equal sign, Lainey?
Minus 2.
Minus 2. All right, so now we're going to solve. We're going to answer. 2 plus 2 minus 2 is going to cross out, and we're going to end up with just y. Y equals 14 minus 2. What is 14 minus 2, class?
12.
That is your answer. Now, if you wanted to check this, you could check it by plugging in the variable amount. And you would do 2 plus, the variable is y equals 12, equals 14. 2 plus 12 is 14. Does it equal out?
Yeah.
It checks out. All right, let's do the next one. X minus 5 equals 15. What is the operation that we are doing in this problem? What are we doing to the variable, Eric?
We're subtracting
We're subtracting 5 from the variable, okay? So what is the opposite of subtracting 5 from the variable? Adding. Adding what, class? 5. Now, whatever we do on one side of the equation, what do we have to do on the other side? The same. So we would add plus 5 over here. We would do plus 5 over here. Now we're going to solve. Minus 5 plus 5 crosses out, and we're left with just x. 15 plus 5 equals 20. That's your answer. Let's see if it works out. Plug in the variable amount, which is 20, minus 5 equals 15. 20 minus 5 is 15, equals 15, and it does indeed check out. All right, what I'd like us to do now is we're going to go to 145. On 145, where we have the practice problems, we've done examples of all of these except for the very last one. So we're going to go all the way to the bottom. And we're going to try this last one, and then I'm going to set you free and you can finish the rest on your own. Okay? So on this one, we have x divided by 8 equals 10. What is the operation we are doing? What are we doing to the variable x? What are we doing to x? Yes? We're dividing it by 8, right? What is the opposite of dividing by 8?
Multiplication.
Multiplying by 8. So the opposite is to multiply by 8. So we would have times 8 equals, and now we got to balance, so whatever you do to one side, you do to the other. Multiply by 8. Dividing by 8 and multiplying by 8, they cross out, and you just end up with x equals, what is 10 times 8? Class? 80. 80. Okay. Now I should have really done this over here. I did that dumb. So we're going to just move this over. So our answer is 80. I'm going to check that. So the check is plugging into the variable 80 divided by 8 equals 10. 80 divided by 8 is 10. So it does check out. All right. So remember your steps. Inverse operation. Do the opposite operation. Whatever the opposite is. That's going to undo and make that variable by itself. Once you've done that, whatever you do on one side, you got to teeter-totter. You got to make it equal on the other side. Make it balanced. So do whatever you do on one side, do it on the other side. And then you're going to solve. And then check your answer if it doesn't seem right. All right? So that is the process of one-step equations. Please finish the final 3 practice problems and add your questions and summary. Have a wonderful day.